We've already talked about factoring trinomials, which remember are polynomials that include 3 terms. So remember, tri means 3, so trinomial means a polynomial with 3 terms. You can see here we've got 2 examples of trinomials. They each have 3 terms. We've already talked about how to factor something like this, but only when there's no coefficient on this x squared term. The coefficient, remember, is the value that sits right in front of the x squared or the x variable. So the coefficient on x here would be 16. The coefficient on x squared here is 6. The coefficient on x here is 10. So that's that coefficient number. And we haven't dealt with trinomials where we have a coefficient on our x squared term other than 1. We've always just had x squared plus these other factors here. So what do we do when we have a coefficient on the x squared? Well, we do the same thing we did before when we didn't have the coefficient. It just gets a little bit more complicated because we have to pay attention to the factors of 3 here, as well as the factors of 5. So if we look at the factors of 3, we know we're either going to have 3 and 1, or 1 and 3, essentially the same thing. And for 5, the only factors of 5 are 5 and 1, or 1 and 5. So now we have to figure out which products we can add together to get this middle number of 16. So we're always going to factor still into these 2 binomial terms here. And because we have 3x squared and we know that the factors are 3 and 1, no matter what order, we can say 3x and 1x, or just x. And that should make sense because if we multiply these back together, 3x times x gives us 3x squared, which is what we started with. So we have our factors of 3 and 1. But how can we get to 16? Well, we know that our factors of 3 are going to be 3 and 1 no matter what the order. So we've got 3 and 1 here, and we know our factors of 5 are going to be 5 and 1 no matter what the order. So it could be the opposite order, but we know we're going to have a 3 and a 1, and we know we're going to have a 5 and a 1. So how do we get to 16? Well, what we're going to do is multiply the 3 by the 5, because that will give us 15, and then we're going to multiply the 1 by the 1, and that'll give us 1. And when we add those together, 15 plus 1 is going to give us 16, which is the middle number that we have here that we need to get to. So we know we need to put the 3 and the 5 together because we have to make this 15, which means that our 5 has to go here, because if we put the 5 in this spot instead, we would never get it multiplied by this 3x. So we have to put it here so that when we FOIL, we have outer times outer. 3 times 5 gives us 15. So we have to put the 5 there, which means the 1 has to go here, so plus 1. And if we multiply this back out, if we FOIL it, remember we're going to do first and then outer and then inner and then last, like this when we FOIL. When we do that, we're going to get 3x times x gives us 3x squared. We're going to get 3x times 5, which gives us 15x. We're going to get 1 times x, which is 1x, or just x. And we're going to get 1 times 5, which gives us 5. And now when we add like terms, the 15x and the 1x go together to give us 16x, and we get plus 5. And you can see we're back to our original trinomial, so we know that we did our factoring correctly here. Now let's look at another example. Here we have 6x squared plus 10x plus 4. And there's actually 3 ways that we can go about factoring this trinomial. So the first thing we want to do is write out our factors. So we have 6 here. The factors of 6 are going to be 6 and 1, or 1 and 6, and 3 and 2, or 2 and 3, so 3 and 2. But either way, a 6 and a 1 or a 3 and a 2 are going to be the factors of 6. Our factors of 4 are going to be 4 and 1, or 2 and 2, and they could be in either order, but we're either going to have a 4 and a 1 or a 2 and a 2. So how are we going to combine these factors to get to our number 10 in the middle? Well, if we take 6 and 1 and 4 and 1, if we multiply 6 by 4 and 1 times 1, we're going to have 24 and 1, and there's no way that 24 and 1 are going to get us to 10. But if we do the 6 with the 1 and the 1 with the 4, we'll have 6 and 4, and that could possibly get us to 10. So we could do here the 6 with the 1, and we could do the 1 with the 4, and that would possibly get us to 10. What about here 6 and 1 with 2 and 2? Well, if we did 6 with 2, we'd get 12, and 1 with 2, we'd get 2. So we'd have 12 and 2, but we'd have to do 12 minus 2. One of them would have to be negative, and the other would have to be positive, and we know that that can't be the case because we have here a positive 4, and because this is a positive, we know our signs have to be the same. So we can't have a positive and a negative, so there's no combination there that'll work. What if we look at the 3 and 2 and the 4 and 1? Well, here if we did the 3 with the 4, we'd get 12, And if we did the 2 with the 1, we'd get 2. 12 and 2, we can get to 10, but we'd have to have positive 12 and negative 2, which again would be different signs, and we can't have that because we have this plus 4, so we know our signs have to be the same. So that's not going to work. But what now if we do 3 and 2 with 2 and 2? Well, in this case, if we do 3 with 2 here, we get 6. And then if we do 2 with 2, we'll get 4. 6 and 4 we know will get us to 10. We can add both of those together, so that's a possibility as well. Well, let's look at our first combination here where we do the 6 and the 1 together and the 1 and the 4 together. In that case, we have the 6 and the 1, so we're going to have 6x and we're going to have x. In other words, 6x and 1x. We know we have to put the 6 with the 1, so we're going to say plus 1. And we know we have to put the 1 with the 4, so we're going to say plus 4. Now, if we multiply this back out, what we get here is 6x squared plus 6x plus 4x plus 4. And if we combine like terms, we get 6x squared plus 10x plus 4, which is back to our original problem, so we know we factored correctly. But what if we look at the other set, the 3 and 2 and the 2 and 2? Well, in that case, we take our factors of 6, so we have 3x and we have 2x, and then we pair them together with 2 and 2. So because they're the same, we don't have to worry about the order, 2 and 2. And if we multiply back out, 3x times 2x gives us 6x squared, 3x times 2 gives us a positive 6x, 2 times 2x gives us a positive 4x, and 2 times 2 gives us a positive 4. We combine like terms and we get 6x squared plus 10x plus 4, which is back to our original problem. So this is another correct way to factor the trinomial. The other way we can think about it, remember we said that there were 3 ways to factor it, is if we look at this original problem, 6x squared plus 10x plus 4, we notice that there's a common factor of 2. We could pull out a common factor of 2, and we would get 3x squared plus 5x plus 2 remaining when we remove that 2, when we factor the 2 out in front. And then we would need to look at the factors of 3 here, which would be 3 and 1, and the factors of 2 here, which would be 2 and 1. And we would be looking to get to this number 5 here in the middle. In that case, if we put the 3 with the 1 and the 1 with the 2, we have 3 and 2, we add them together, we get 5. So what we'd have here is we'd factor this like so. We have our factors of 3, 3 and 1, so we'd get 3x and 1x, or just 3x and x. And then we want to put 3 with the 1, so we'd say plus 1. And we want to put the 1 with the 2, so we'd say plus 2. And if we multiply this back out, we'll get back to our original problem. And you can see that this is true because if we compare this answer to the first answer we got, we have this x plus 1 factor here. We have an x plus 1 factor here. And then we just have 3x plus 2 with a 2 factored out. And if we look at this 6x plus 4 here, we could factor a 2 out of that and get 2 times 3x plus 2, which is the same value that we have down here. So we've essentially factored it the same way, we just pulled out the 2 at the beginning.